A single aircraft carrier costs more than the entire annual budget of many countries. It takes over a decade to build. It carries enough firepower to reshape the balance of power in any ocean on Earth. And when the U.S. Navy decides to launch one, the process is so massive, so complex, and so precise that even the smallest mistake can cost billions of dollars and years of work. This is not a ship. This is a floating nation. And today, you are going inside the entire process of how one comes to life. Introduction. Most people never get to see what happens behind the fences of a military shipyard. The cameras don't usually go in, the public doesn't usually ask, but what takes place inside those yards over years and years of brutal, skilled, and deeply patriotic work is one of the most extraordinary engineering achievements in all of human history. We are talking about a vessel that is 1,100 feet long. That's longer than 3 football fields placed end to end. It weighs over 100,000 tons when fully loaded. It carries dozens of fighter jets, thousands of sailors, its own hospital, its own power plant, and enough food and supplies to operate completely independently for months at sea. And building one from scratch? That process will absolutely blow your mind. So if you're someone who respects the strength, the sacrifice, and the sheer brilliance of the U.S. military, drop the word proud in the comments right now. Because what you're about to see is a testament to American power and engineering that very few people ever fully understand. Let's get into it. Where it all begins. The design phase. Before a single piece of steel is ever cut, the carrier already exists, completely inside a computer. That's not an exaggeration. The USS Gerald R. Ford, America's most advanced aircraft carrier currently in service, was fully modeled in 3-dimensional digital form years before any physical construction began. Every single compartment, every pipe, every wire, all of it mapped out digitally first. And we're talking about over 3 million individual parts. 3 million. In a single ship. The reason this matters is because the slightest design error discovered after steel is already welded together can cost tens of millions of dollars to fix. So the Navy and its shipbuilder, a company called HII, Huntington Ingalls Industries, invest enormous time and resources into getting the design absolutely perfect before construction ever starts. For the newer USS John F. Kennedy, which is currently in late-stage construction right now, HII made an important decision early on. They locked in the entire design completely before cutting the first piece of steel. No changing course midway, no adjustments after the fact. The full blueprint, finalized, before anything physical began. That discipline alone saved over $1.5 billion compared to the cost of building the Ford. The design phase covers everything, where the nuclear reactors will sit, how the flight deck will be laid out, how ammunition moves from deep in the hull up to the deck, where sailors will sleep, eat, work, and fight. It is a city. And like any city, it has to be planned with extraordinary detail before the first brick is ever laid. But here's what most people don't know about what comes next, and this is where the real magic starts. The steel cutting and the superlift method. Once the design is locked in and approved, the shipyard comes alive. Massive plates of specialized high-strength steel designed specifically to withstand both the pressure of the ocean and the impact of combat, begin arriving at the yard. Workers cut this steel using precision tools, heat it, bend it into the exact shapes required by the digital model, and begin assembling smaller sections called blocks. These blocks are then joined together into much larger structures. And this is where a method called modular construction, or the superlift method, completely changes the game. Here's how it works. Instead of building the ship in one spot from the ground up, workers build large sections of the ship separately, on land, away from the dry dock. Each of these sections, called superlifts, can weigh hundreds of tons. And here's the key. Before a superlift is ever moved to the ship, almost all of its wiring, plumbing, and interior systems are already installed inside it. So when that massive section gets lifted by a giant crane and lowered into its exact position on the hull, it's not just a steel shell. It's already got its veins and nerves inside. Workers then weld it to the surrounding sections, and the ship grows piece by massive piece. Construction starts at the very bottom of the ship and works upward. The inner bottom comes first, then the side shells, then what are called box units, the mid-level structural layers that give the ship its immense strength and internal structure. By the time the bottom third of the ship is complete, it already looks like something out of a science fiction film, a metal canyon sitting in a dry dock, slowly rising. And speaking of the dry dock, let's talk about that. The dry dock, where giants are born. A dry dock is essentially a giant concrete bathtub. It sits at the edge of a river or harbor, and it can be flooded or drained depending on what stage of construction the ship is in. When work begins on a new carrier, the dry dock is completely drained. The enormous keel blocks, wood-capped concrete pads, are placed in precise positions across the floor of the dock. These blocks will support the entire weight of the ship during construction. We're talking about a structure that will eventually weigh over 100,000 tons resting on those blocks. Every single one has to be perfectly placed. The keel-laying ceremony marks the official beginning of the ship's life. In modern shipbuilding, the keel isn't a single wooden beam like it was in the age of sailing ships. Instead, it's the moment when the first large module is lowered into the dry dock and officially joined to the structure. It's a ceremony attended by Navy officials, shipyard leaders, and sometimes members of Congress. And it carries real emotional weight, because from this moment forward, this ship has a name, a number, and a future. For the USS John F. Kennedy, hull number CVN-79, the keel was laid in 2015. From that moment, over 3,200 skilled shipbuilders and more than 2,000 suppliers from across the country began pouring their work into her. Now here's something that will put the scale of this in perspective, and this is the part that most people completely miss. Before we go any further, please take a second to like this video and subscribe to the channel. Over 98% of viewers watch without ever subscribing. It costs you absolutely nothing, but it makes a huge difference to us. Hit that subscribe button right now, and let's keep going. The scale that defies belief. To build a modern U.S. Navy supercarrier, the shipyard doesn't just need skilled workers. It needs its own small economy. The dry dock at Newport News Shipbuilding in Virginia, the only place in America where nuclear-powered aircraft carriers are built, is so large that it can hold 2 carriers under construction at the same time. And in November 2024, that's exactly what happened. I announced that for the first time in history, 2 Gerald R. Ford-class carriers, the USS Enterprise and the future USS Doris Miller, would be under construction in the same dry dock simultaneously. The Enterprise's mid-body hull section was carefully floated to the west end of the dock, and construction on the Doris Miller began in the east end. 2 of the most powerful warships ever built, growing side by side. The numbers involved in this process are almost impossible to wrap your head around. The flight deck of a Nimitz-class carrier covers about 4.5 acres. The ship stands as tall as a 24-story building from its keel to the top of its mast. It has over 4,000 compartments, rooms, corridors, workspaces, connected by miles and miles of corridors and stairwells. It generates enough electricity to power a small city. And onboard desalination plants can turn 400,000 gallons of salt water into fresh drinking water every single day. Now, keep watching, because what happens when the dry dock floods is one of the most visually stunning and emotionally powerful moments in all of military engineering. The flooding, when the giant wakes up. After years of construction inside a completely dry dock, the moment finally arrives. The gates open, and 100 million gallons of water begin pouring in. The flooding of the dry dock is done slowly, carefully, and in multiple phases. It doesn't happen all at once. The dock is first filled to just about 10 feet, enough to reach the keel blocks, and then engineers run a series of checks. They look for any signs of leakage, any structural stress, any unexpected movement. Every measurement matters. Then, as the water rises further, the ship begins to lift. For the very first time, after years of sitting on concrete blocks in a dry dock, the hull separates from those supports and floats. Workers and engineers who have spent years building this machine stand at the edges and watch. Some of them have spent 5 or 6 years of their lives on this single ship, and now, for the first time, she is alive in the water. When the USS John F. Kennedy's dry dock was flooded back in late 2019, the process took several days. Over 100 million gallons of water. Gradual, precise, controlled. And when Kennedy finally floated for the first time, she was moved to the west end of the dry dock, where the next phase of outfitting would continue. This moment, the flooding, is called the christening and launch. It is one of the 4 great milestones in a warship's life, and it is the moment that marks the shift from construction to activation. But the ship is nowhere near ready to go to sea, not even close. Because now comes one of the most technically demanding phases of the entire process: outfitting, installing the brain and the muscle. After the christening, the carrier moves to an outfitting pier, a long dock where workers continue installing everything that makes this ship a warship rather than just a very large steel hull. This is where the nuclear reactors go in. This is where the weapons systems are mounted. This is where the radar arrays, the communications towers, the combat control centers, and the advanced electronics are installed and connected. And this is where 2 of the most revolutionary and most challenging pieces of technology on the Ford-class carriers live. The first is called EMALS, the Electromagnetic Aircraft Launch System. On older carriers like the Nimitz class, aircraft were launched using steam-powered catapults, a system that worked for decades but had real limitations. EMALS replaces steam with electromagnetic energy. It uses the same basic principle as a railgun, a linear electric motor that accelerates the launch bar attached to the aircraft and hurls it down the flight deck. The result is a smoother, more controlled launch that puts less stress on the aircraft's airframe and allows for more launches per day. During testing of EMALS on the Kennedy, engineers used large wheeled structures called dead loads, weighing up to 80,000 pounds to simulate the weight of real aircraft. These dead loads were launched off the bow of the carrier, flying through the air and splashing into the river. Test after test, adjusting the system, refining the output, making sure it works flawlessly before any actual aircraft ever touches that deck. The second system is called AAG, Advanced Arresting Gear. This handles the other end of flight operations, catching the aircraft when it lands. A landing fighter jet hits the flight deck at over 150 miles per hour. The AAG system uses an electromagnetically controlled cable to catch the aircraft's tailhook and bring it to a stop in just a few hundred feet. Getting this system right is just as critical as EMALS, because a failure on landing is just as catastrophic as a failure on launch. Both systems cause significant delays on the Kennedy's construction timeline. Issues with the advanced weapons elevators, the systems that move ammunition from the ship's deep magazines up to the flight deck, also push the schedule back. As of early 2026, Kennedy's delivery date has been pushed to March 2027, with an estimated acquisition cost now sitting at over $13 billion. But here's the thing about why that cost and that timeline are worth every penny, and this is something that every American who respects the military should hear. Why it takes so long, and why it's worth it. There is no other weapon system on Earth that projects power the way an aircraft carrier does. When the USS Gerald R. Ford and the USS Dwight D. Eisenhower both operated in the eastern Mediterranean at the same time in late 2023, as the situation in the Middle East intensified, their presence alone changed the calculations of every country in that region. No missiles were fired from those ships. No jets launched strikes. Just their presence, 2 floating air bases carrying dozens of the most advanced fighter jets in the world, was enough to send a message that no other nation on Earth can send. That is the power of an aircraft carrier. And that power takes time to build correctly. From the initial steel cutting ceremony to the day the ship is officially commissioned into the U.S. Navy, the entire process takes somewhere between 8 and 12 years for a modern supercarrier. The USS Gerald R. Ford was laid down in November 2009. It was commissioned in July 2017, nearly 8 years. The Kennedy has been under construction even longer due to the new technologies being installed and refined. But each generation of carrier is smarter, more capable, and more powerful than the last. The Enterprise CVN-80 is the first aircraft carrier in history to be completely designed and built entirely through digital platforms. Every decision, every component, every system mapped in digital space before a single weld was made. It is scheduled to be launched in late 2025 and delivered in 2028, and the carrier after that, the USS Doris Miller CVN-81, is already being assembled in the same dry dock right alongside the Enterprise. The future of American naval power being built right now, side by side. Sea trials. The final test. Once outfitting is complete and all systems have been tested at the pier, the carrier heads out to sea for the first time under its own power. This is called sea trials, and it is exactly what it sounds like. The ship is pushed to its limits in open water to prove that everything works the way it's supposed to. The engines are tested at full power. The steering systems are checked. Every radar, every weapon system, every communication link, activated, tested, and verified. Sailors who have been assigned to the ship for months already, learning its systems and its layout, now run through their duties in real conditions for the first time. In January 2026, the future USS John F. Kennedy left port in Newport News and began its initial sea trials, a historic moment that HII described as the result of years of selfless teamwork by thousands of shipbuilders, suppliers, and crew members. These trials will test every critical system before the Navy formally accepts the ship. After sea trials comes the delivery, the moment the shipbuilder officially hands the keys to the U.S. Navy. And after delivery comes the most emotionally powerful moment of all. Commissioning. The ship comes alive. The commissioning ceremony is when a warship officially joins the United States Navy. It is a formal, deeply moving event. The crew stands at attention in their dress uniforms. Officers read the commissioning orders. The ship's sponsor, often a woman chosen to represent the spirit of the ship's name, gives the command that every sailor on deck has been waiting for. Man our ship and bring her to life. And with that, the crew sprints aboard. The ship's flags are raised. The national anthem plays, and a vessel that began as a digital model that was built piece by thousands of workers over nearly a decade officially becomes a commissioned warship of the United States Navy, ready to defend the nation, project its power, and serve wherever she is needed. It is one of the most powerful traditions in all of the U.S. military, and it is a tradition earned through years of extraordinary effort by shipbuilders, engineers, sailors, and the families who support them. Conclusion. What you just watched is not just an engineering story. It is a story about what this country is capable of when it commits to something. It is a story about the men and women who dedicate years of their lives to building the most powerful warships in human history. And it is a story about why the U.S. Navy remains and will remain the most dominant naval force on the face of the earth. If this gave you a new appreciation for what goes into America's military strength, hit that like button and make sure you are subscribed. There is a lot more where this came from.